All right, we'll get started here. Can I get a mic check from everybody to see if you're here? Will?
Hey, Professor.
Okay, checking 1, 2. Sheev, I think, right?
Yep, check.
Ah, you're terrible. Can hardly hear you. Probably have your mic far away. You there? One more time, Sheev.
Let me try it in a few minutes.
All right, no problem. Nasher, you there? Mic check. Alden?
Here.
All right, I hear you. Nasher, you there? Might be having trouble with his mic, or he may just disappear. All right, so even though it's three of you, it's 4:30. We need to get moving. Can everybody see my screen?
Hello, Professor. I'm here. Sorry, I'm having problem with. I'm at the work computer, so I'm having problem with the mic.
Yeah, no, that makes sense. That makes sense.
But
Well,
yeah,
hopefully you can still work with your team when you get together in your team project. All
Yes,
right, all
Hey,
right.
can you hear me
So
now?
yes, I can hear you
Okay,
now, Chef. And
perfect.
by the way, you can see my screen, right? Can everybody see my screen? You can raise your
Yes.
hand. It looks
yeah.
like you can see it. All right. And now lower your hand. Don't raise it unless you have a question. All right. Good. All right. Let's get started. What basically what we're going to let me just go through these quotes of the day. The reason I like them is they kind of try to talk about the importance of certain things or knowing certain things. Will Rogers used to say, "It isn't what we don't know that gives us trouble. It's what we know that ain't so." In other words, you think you know something, but it's wrong. The other thing, Albert Einstein, is it's a great quote. I've seen it on people's signature blocks. It says, "Not everything that can be counted counts, and not everything that counts can be counted." The very aspect of trying to understand um, what is important and what we should be looking at. And that kind of segues into what we are here for, which is the next class. So you should have homework 2 uploaded by the end of the day. I'm sorry I haven't gotten to your team plans. I hope to get to that tonight or tomorrow and give you some feedback on that. And of course, if you have some questions about the presentation for the CDR, which is in 2 weeks, we'll hang out after class today. All right. So today we're going to talk about technical evaluation and readiness. And again, homework number 2 should be due. I'll be assigning another homework today. So technical evaluation and readiness just kind of prepares us for the fact, are we ready to get into implementation, integration, and tests? So what I'm going to do is talk about technical evaluation. What does it mean to measure things? There's different ways to do measurements when you're in a system engineering project. And we'll talk about MOEs, MOPs, and TPMs. Kind of did that on the extra class that we did. And we're going to cover it again. Maybe not to the same extent as that, but we'll answer any questions if you didn't quite catch it that first time around. And then we're going to cover technical readiness, and that's really trying to do a decision analysis and looking at technical and design reviews. In other words, what are decision gates? All right. So why are we doing measurement? Actually, it's a great quote from the System Engineering Program Metrics Panel. They say technical decision makers do not have the right information and insight at the right time to support informed, proactive decision making, or they may not act on all the technical information available to ensure that effective and efficient program planning, management, and execution is occurring. So measurement is the things that will solve these issues. So the purpose of measurement, if you look at 15288, the System Engineering, International System Engineering Stand, they actually talk about measurement process of collecting, analyzing, and reporting that data. Now, there's a two-prong aspect to measurement. Number one, it worries about the product that's being made. In other words, the system itself, as it's being made. Is it a quality project? Is it actually meeting the needs of the user and the actual stakeholders? So you're trying to support and objectively demonstrate the quality of the product that you're trying to make. Now, the other thing is the actual processes implemented by the organization to make that product. So actually understanding those processes and making sure those are measured correctly, because if any of the processes are off, your product will be off. So measuring not only the health and wealth of your product that you're making, but the health of your processes as well. So it helps to, what you're trying to do with measurement is define the types of information needed to support program management and technical decisions and implement the best practices from a system engineering point of view to improve performance. So that's straight out of the handbook. As you can see, even in that little definition, it talks about implementing both program management and technical aspects. So the key to good system engineering management is to make sure that your measurement aspects of either your products or your processes, that the measurement's timely, that it meets whatever requirements or quality attributes that you feel has to be in place, that you're actually conforming to perhaps some standards that are in place, and you're using your resources correctly, and you have a means to continually improve that measurement aspect of your project from a cost and time cycle standpoint. So basically what you're trying to do is communicate with your measurements effectively throughout your organization. You're trying to identify problems early. If you do these measurements in such a way, they can be an indicator of future problems, and you really want to try to catch those. They help you understand your trade-offs that you're working on, and of course, tracking your project objectives makes sure that you can actually meet those objectives. And defining and justifying whatever decisions are made, measurements can kind of back you up as you're going into that. So there, and keep in mind, this is part of a larger management process. You're making measurements in order to support some kind of stakeholder who needs to understand where the project stands, either in terms of the processes that are being used or the system itself that's being built. And it's not just program managers. There's a lot of times system engineers, analysts, designers, developers, integrators, logisticians, people who worry about logistics. And other people may actually have a vested interest in some of the measurements that are being made. So communicating that information, that the measurement that's being made to the decision makers is one of the key aspects to make this work. So a lot of times measurement is giving you the knowledge you need in order to effectively perform in your project. You need to know what status, where you're at. You need to observe if there are trends that are going to indicate that you're going in the wrong direction. You need to compare the plans you made to what's actually going on, seeing if you're on track or if you're actually in trouble because there's a deficiency there. Also, you need to use measurement to make you understand how big the problem is or the risk that's involved. Also, trying to understand the complicated aspects of relationships that are out there and all. And if your measurements are done right, you can ask the right questions, develop a database to give you a good estimate on future planning and future projects, and try to improve processes or your product via quality improvement process, all through measurement. And that's where it becomes important. Now, measurement is so key that in COSI actually has a whole list of measurements that you can use, be it software management processes or capability maturity model, PSM, which is the process systems management, those practical software measurement. A lot of references that you can go to and find more information about this. And I provide you links into this PDF that I provided you for this lecture. So when you look at measurement, you should think about the actual control system, the resource, process, or product that's involved, and what kind of value comes out of measurement. The last thing you want to do is do measurement for measurement's sake, right? You want measurement to have a purpose. What kind of resources are used, and you can actually measure your resources and the way they're used that are part of the process that's used, and you can measure that process and see if the process is being used right. And then the actual work product that is actually an output of the process, that can be measured as well. So those 3 points actually give you an idea of the measurement. You analyze those various measurements that are coming out, and you take action in order to improve the processes. If you improve the process, your work product should improve. So your decisions actually should come out from the fact that you're actually taking some measurement values of the actual. And normally you have a target you're going after. Are you meeting that target? Or are you over that target? So the whole idea of looking at measurements from both the development processes, like what kind of staffing or requirement approvals, or your actual product performance, what is that system I'm creating? Is it meeting its weight requirements? How about its product speed? And things like that. Those type of performance measures also tell you if the system is doing well. But each measure has a different population. The development processes, like for staffing and requirements improvement, very program management oriented, whereas the actual product performance would be after the stakeholders of the user or the actual people that need the product. So different stakeholders, different measurements. Again, 2 focuses, the process and improving that, and the measurement. If you look at the process ones, you're kind of looking and tracking how the processes are going, and you're trying to make sure that you lower the risk as much as possible by ensuring your processes do meet the concerns and the objective of the organizations. And you can kind of look at process measures from a development standpoint, like cost, schedule, or even quality. Is your process is being followed correctly? Part of that is thinking about leading indicators. Now, what happens there is you look for various aspects of measurements that can give you a kind of a short understanding that something's going to happen. Like, what is the furthest you can take this measurement that will lead you to understand? It's almost like, is it smoldering a little bit? Is there smoke coming out? Is it a whole up fire? You need to look at when is the best time to look at it and get that information, and then look forward and see how it's doing. So leading indicators is a great way to actually do your measurement so that you can analyze it and forecast what is about to come to pass. And here are just a few. Like, for instance, you can look at requirements and see how the maturity of the system requirements versus the plan to actually get the system that based on those requirements out into the field. And if your system requirements are not stable and they're not complete by a certain time, your time frame to meet the deployment of that system is in jeopardy. So you can actually look at the trends of the maturity of your system definition in order to give you an understanding if you're going to meet the actual schedule of your project. Interface trends is another one, because eventually you need to integrate all these pieces and parts and external products together. And if your interfaces aren't keeping up with the rest of the system as it's being built, it can actually be a tripping point for trying to deploy. And of course, validating the requirements. Remember, when you validate the requirements, you give it to your stakeholder, and you actually make sure that they agree that these are the requirements. If you can't get that validation, you can't be sure if they're going to be happy with the system that you're making or not. The other one is product-oriented measures. That's where you look at MOEs, KPPs, which key performance parameters, MOPs, and TPMs. And one builds on the rest. You really can't have MOPs without effective understanding of your MOEs. So measures of effectiveness kind of derive your MOPs, your measures of performance, which are then derive your technical performance measures. So you'll remember this. We talked about how the MOEs is that operational measure of success. In other words, it's always your mission. Is your system meet its mission requirements? So you always look at it in terms of the achievement of your mission or your operational objective that's being evaluated. And you have to make sure it's in its environment, of course. But basically what you're trying to do is make sure that the solution achieves whatever intended purpose that the system is being built is for. So it's always from the customer or user viewpoint, but it's a great indicator to figure out if you're going to achieve the mission or not. Very important. The other one is MOPs. Now, MOPs measures that characterize physical or functional attributes relating to the system, its operation, and it's measured or estimated, again, under very specific either testing or operational environment concerns. This is an attribute that worries about the system as a whole, and it just wants to know, does the system meet the way I designed it, the requirements that I put forth. Key performance parameters are usually a subset. If you think about MOPs, they're every single aspect and function of your system could have an MOP. Key PPs say, let's pull out those subset that are critical for the performance to be made. And any failure in any of these key performance parameter means the whole system will come crashing down. So let's remember this. Raise your hand if you remember the famous getting 6 troops over the mountain. I want to make sure everybody is covered. Just hit the little raise your hand button. Knew it. I'm bored. Oh, okay. So you guys don't remember this. Huh. I wonder if I should start over again. All right. Maybe I'll do that. Maybe I'll do a blank. Let me do that. Now, if I do that, so not okay, let's do it this way. How many of you not seen the troops going over the mountain scenario? Raise your hand. It's one or the other. Am I on? Is my mic on? Nobody's doing anything.
Yes, you're on.
Okay, so I can't.
We have seen it.
Okay. I cannot see your hand raised. My goodness. Okay.
Well, I've lowered it, but now it's raised.
Okay. Raise your hand again so I can see. Okay, I don't. There you are. Alden, how about you? Have you seen it? No?
Honestly, I mean, my hand's raised. I'm just kind of getting tired of these technical issues, but my hand's like raised.
Sorry about that, Alden. Doing our best here. All right, good. I see your hand. The rest of you have not risen your hand. If you have, I apologize. I do not see your hand raised over here. Let me, you guys have seen it. Go ahead and lower your hands. The rest of you, I assume maybe you don't remember the famous mountain and the TPMs. You guys remember this at all? You guys can come off mic if the hand isn't raising. Yeah, it's all right. Yeah, that's something. Nobody? All right, let me try to work this for you. Basically, there were 6 troops. We're trying to get them over the mountain. I asked you guys to come up with some ideas for us, like either tunneling through the mountain or getting a jet car. We kind of settled, or even a robo assistant, trying to work through. We figured the MOE is the actual time to go from A to B. Again, it's very mission oriented. Doesn't depend on the system. System has to produce the result, but your MOE is the same no matter which system you use. And then we had your MOP, which is based on your system. In the helicopter example, we actually said the miles per hour of the helicopter would actually indicate if you could meet the mission or not. And then we looked at the TPM, technical performance measure, and we looked at the part. And the part was the engine, and we felt it's the horsepower of the engine will give you the speed or the miles per hour, which will allow you to meet the MOE. So as you can see by my thing here, your TPMs are derived from your MOPs, which are derived from your MOEs. All right. So everybody good there? So TPMs is where the program manager actually starts looking at, are we going to meet the MOPs and the MOEs? And this is in the midst of building your product. So this is just a few examples of the way you can actually use charts and other things to actually show where your technical performance measure is by looking at where you feel it should be and where it is right now and your estimate to get there. So usually you use them to forecast perhaps values, like you're trying to look at the KPPs, or you're looking at what you're planning and what is actually happening. That's the other thing. Assessing your progress of achieving your key performance parameters, looking at the differences between your actual and the actual what you expect. If that impact of those differences is great enough, you can actually identify a greater risk, and you may be able to put more resources on it. But it's a good way to monitor your technologies you're using, or the new fangled processes you may be using, to make sure that indeed you can meet the MOPs and eventual MOEs as well. And this is a way that you, through a single graph, you can give a lot of information about where your TPM is versus where you need it to be. And if you don't meet the TPM, you get into a high risk area. So that's one way to report it. This is another showing this is my planned, this is my tolerance. Am I in the middle? Can I get above it? It's another way of looking at it. So MOEs are very mission oriented, so it's way above here in the system at the mission realm, where you're finally understanding what the system should look like. That's where you get these detail and high level design. And that's when your MOPs come into play. And then of course your TPMs are when you're actually in the detailed design of the parts that you're trying to make, and when you implement those parts together. And you trace your MOE all the way to TPMs back up. So it gives you a lot of insight on the shifts that may be occurring as you go through the development process. Here's an example. For instance, you could have an airplane like this, and the airplane needs to go and actually meet its range. It needs to go a certain amount of miles in order to either get to the next airport or to go out and then come back to its previous. So your maximum range is an important aspect of it. Well, what does that mean from a plane, from a system standpoint? Well, you could derive your measure of performance of your miles per gallon based on how many nautical miles you have. So your MOE is how far you need to go. Your MOP is how much fuel you need to do that. Sorry about that, guys. We should minimize that. Let me make sure that's lowered. Sorry. And then the TPM would be the part. It would be like your tank, your fuel tank. How many gallons can I put in there? So that's kind of one way of looking at TPMs and technical measures and how it works. Another thing is like a satellite. If you have a satellite that actually needs 35 corrections throughout its 8-year life cycle, that's your estimate of how many corrections are needed, you'll need some kind of propulsion. So that way you may want to look at your battery and your solar cells. And out of that, and propulsion capacity. Out of the propulsion capacity, you actually look at the volume allocated to the propellant system. So you have to look at the mass of your satellite, your efficiency of your thruster, and the effectiveness of your propellant itself. Out of that, you need to understand how many gallons do you need, how many liters, I mean, in order to make this work. So that becomes your MOE, service life 8 years, MOP, propulsion capability of 35 corrections, TPM, I need 17.5 liter tank on there. And of course, you can monitor it through different ways. Notice here, this is about battery size. And as you go in, you can start actually doing direction where once you understand perhaps the capacity is going down, you may actually have to go in and do some modifications to the design. So you're doing that. So that's the whole idea of looking at all of the measures in themselves. So remember, do not measure for the sake of measurement. A lot of times you may wind up being in a project where they're doing the same measurement they did for the last project, and nobody's ever questioned it. So if you find yourself in that situation, go ahead and question it and make sure that indeed it does add value to what you're trying to accomplish. And you may actually, at every design review or every decision meeting that you have, actually review the requirement, the measurements that you're making, and make sure the stakeholders still need them as you go forward. So remember, measurement is one part. It's what you need. It's the data input you need for your analysis. And then once you do your analysis, you have to initiate resources to get that improvement, be it in the system or in the processes themselves. Of course, the best measures are ones that require little time and little effort, but that doesn't happen much, but it's nice when it does. So measurements, a process, it's not a predefined list of graphs and reports. You need to develop those based on the system you're building and the project you're in. And your data collection and analysis must be planned out and together. Don't just, do measurements and don't analyze it. That doesn't help anybody. And be flexible with your measurement program, because there may be times you're taking the measurement and you're finding you're taking the wrong measurement. Can you pivot and start taking the right measurement? and make sure that information that's coming from the measurement is available to everyone in the team. All right, let me stop here. You can open up your mic if you have some questions. I don't know if I was that clear. You guys feel comfortable with MOEs and MOPs?
Yeah, I think so.
Okay, good. Thanks,
Yeah.
Will. Thanks, Rohit. All right, well, let's see if you guys can go into your teams, and let's develop a MOP and TPM based on the, you should have described your function that would have described kind of the MOE for your pomegranate. You should have done that already. Let's see if that's true. Let me pull this up. Oh, right. Let me do this real quick. How do I? Oh, yeah, right here. Nope. Nope, 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 nope. Sorry, guys, I'm trying to find it. There it is. All right. You should be able to go into your files here, and you should be able to. It's one of these exercises. I forgot which one. We'll have to bring them up. But you want to open up exercise 1. Go ahead and probably copy and paste your MOE in here, and then figure out what your MOP and TPM would be for your actual function that you're trying to create. So go ahead and get into your teams over here. I'll be able to see that you have started up a team meeting. I'll probably pop in to see if you have any questions. And let's only make this a few minutes, about 15 minutes. At 5:15, try to come back to the main teaching here, okay? So go ahead, and I'll see you in about 15 minutes. If you have any questions, I'll be hanging here, okay?
Yo.
Yo,
Oh.
go to your class. Yeah, I mean your team.
I am. I went to my computer. I thought it automatically. I use my phone and my computer, but it
There
doesn't.
you go.
Yeah, it doesn't automatically change it. You'll need to end the call before you start a new one. Okay. I already did that. Oh, gosh.
Really? Isn't it? Team 3's done. Oh, hey guys, Team 3's done, huh? Might do you first. Is that right? Good. All right. Excellent. All right. Welcome back, Team 4, I think, right? I think it was Team 4.
Yep.
And I think I'm waiting on Team 2.
We're back now.
Team 2's back. Great. All right. I think is Team 1 here at all? Anybody from Team 1? Did they just kind of? Okay, Will's back. Team 4 is not back. Nope. Team 4 is back. Okay. Anybody from Team 1 here? Precious, Shadoob, Kelajic, is he here? Anybody? Ah, so Team 1's not here at all. That's weird. All right, let's go ahead and pull up Team 2's file. I believe that's this one right here. All right, talk to me, guys.
Yeah, this is Rohit, so I can present this. So we have the MOEs for our pomegranate voice translator already written in the previous exercise. So to update on the MOPs, we have within the 1 second the device must determine the language spoken to it, and within 2 seconds after the speech ends, the device will translate it into a desired language.
Oh, that's good.
So as the metric is time, so we have the unit second, and for the TBMs, we have the language database, the Google Translator database, and the microphone and speaker sensitivity. So for that, the metric would be code or the
Oh,
database
right.
or data.
Okay, so you
And-
had several things. Okay.
Yeah.
Yeah.
And
No, I was just wondering, I mean, you're worried about the time? Um, is it the time the Google Translate occurs? I mean, you'd have to time that, right?
yeah, but this what we have mentioned in the MOP. So as soon as the device will try to determine the language, it will go into the database and look for it within the 1 second time gap.
Oh, I see what you're saying. Okay.
Yeah, and
Okay.
that's how it will choose the language and try to translate the audio output, whatever the speaker says, into the translator.
Man, that's okay. So why did you put the metric as code? I don't see how lines of code.
Yeah, that's supposed to be slogs. It's gotta be the program or for writing or input for the database.
Yeah, I know that, but how does that? Why does the measure of lines of code give you the TPM to allow you to understand your MOPs being met?
We were actually not sure about it. We were just trying to put a guess. So,
Yeah, they weren't quite sure about what to put for the units.
yeah.
Because I mean, it measured the amount of the seconds,
Or
but then
we
yeah,
could just have written data. Would that be fine? That should be.
Yeah, now that would make sense in
Yeah.
terms of the speed of your data being attracted or being able to stream your data in such a way to the database. That would make sense.
Yeah.
Okay. So I didn't give you a lot of time on this, so that makes sense. I mean, what you've tried to do, one of the things I will want you to do is try to run one of your functions in your project together. You should be able to pull it all the way down to the TPM and have it kind of make sense. That's what's important. Okay, that's team 2. That's and nobody from team 3. We're pretty obvious. Okay, just want to make sure. All right, let's pull you guys up, see what you look like. So who's going to talk for the coffee men here?
I got it. Can you hear me?
Yes, I can, Jordan.
Okay.
Thanks.
So our MOE was a measure of time. So like the amount of time it takes the coffee to be brewed and poured into a coffee mug. The MOP was measuring the rate at which the coffee flows from being brewed to the cup. So
That's good.
milliliters per second. And the TPM is volume, using milliliters as a standard measurement of volume. So.
Right. And there, you may notice that the MOP also requires your plumbing or your pumping right system. That has to pump a certain rate too. So yeah, no, that makes sense. You guys did good. But notice you usually have a lot of TPMs to make up one MOP, and you may have several MOPs making up a MOE as well. So good job, guys. Good job. All right, who's going to speak for number 4? Anybody?
That was number 4. That was us.
Oh, you're kidding. Class 4? That was class 4? Nope. Number 4 is the Razor. Team 4.
Oh, my bad.
It's all right. You're team 3, I think. All right, so what do you got?
Wait, who just spoke? I thought that was
The coffee men
Oh, okay.
as team.
Okay. Well, just basically, we didn't really have our MOE, so we kind of created them. Razor needs to be able to remove hair, and then we figured each downward stroke, just one of them from that MOE would eliminate a surface area, and then 10 blades for the TPM. You need 10 blades, and then each blade has to have a width of 6 centimeters.
Oh, interesting.
Kind of deliver that. measure performance.
That's good. Okay. So no, I like what you did. So the width of the thing, and of course that's context-wise in relationship to the phone itself. So good. You guys all did good. Excellent. Excellent. All right, let's move ahead and get to the next part of what I want to teach you, which is really about the whole idea of doing trade studies and how to get information so you can make proper decisions. As a matter of fact, I have new quotes. There's this really old Art of War document that's been around for 6,000 years, and actually 8,000 years. And in there, the general said, if it's a matter of life or death, a road either to safety or ruin, it's a subject of inquiry. In other words, you need to think about it. And it can be no account be neglected. In other words, you need to inquire about it fairly intensive. And then about 2,000 years ago, this Jewish carpenter out of Nowheresville happened to say this really neat quote about how when you're trying to build a tower, and you should be sitting down and count the cost, because if you don't count the cost, you can't finish it, and everybody's going to laugh at you. And so you just need to be sure that you're ready with your project, that you actually look at how you're going to actually translate this whole, I did measurements, how do I make decisions out of them? So this is a thing called technical readiness, where you come up with a solution, you have this solution space, eventually you figure out the functions and the architecture and figure out your subsystems and components. Well, to actually go from the final product, you need to have a good understanding of your problem space. So you're going from one to the other. So to actually figure all that out, you have this thing called trade studies. And actually, if you look at the DoD life cycle from milestone A or pre-milestone A to milestone C to deployment, you'll actually see trade study after trade study after trade study after trade study, each one based on where you are in the life cycle. So it's a very important framework as a system engineer to be able to make these sound decision-making aspects relative to trade studies when it comes to performance, risk, cost, and schedule. So whenever you have one or more alternative paths to go, you need to have the ability to do this type of thing called a trade study. And we actually have various examples. You could perhaps look at what kind of technical solutions you may have to go with, or you may actually document the actual information for that technical trade study. There are a lot of techniques, and that's actually gets a little confusing at times, but it depends on where you're going with your trade study, what kind of information you have, and what kind of result that you're looking for. And you don't want to standardize on one technique. You kind of want to learn as many as you can, but pick the right one for the right situation. Now, what I'm going to show you here is actually out of the handbook, the System Engineering Handbook, and it actually talks about the key activities for a trade study. One, you think about the context, the scope, or the constraints of your trade study, frame the problem. Then you establish a communication with your stakeholders, make sure they understand how this problem is being framed. Then you work with them and say, what kind of evaluation criteria and weights would you be comfortable with? And then you actually go out and look for candidates or alternatives and actually try to see which is the best way to go for you as you're doing that. So figure out your alternatives and select those. Then you figure out your measurements that you're going to use to figure out you know, are these candidates worthy of considering? And then you analyze the results between the various candidates and you pick the right one, best one. Then you review that, your whole trade study with the stakeholders, reevaluate if you have to. And then you try to think, okay, if I actually implement this trade study, what would be the implications? And then do scenario planning to make sure your assumptions about how this would be used would actually come about. So evaluating and trying to come up with your criteria, especially when it comes to weighing things, is an actual technique itself. So I have techniques for trade studies, and within the trade study, I need a technique to figure out how to weigh these criterias. And you have one thing where you can score them against a fixed criteria maybe, or you could do this pairwise comparison, which uses eigenvalues and matrices. But you know, whatever you use, make sure you include that into your trade study, and you try to get as many individuals as you can to figure out what your evaluation criteria is. And you should confirm that criteria and the weights that they are indeed appropriate for whatever type of concept selection you're using. So this shows you kind of the process. You define that decision statement, then you establish the criteria. With the criteria, you can say, what are my wants? And you can weight those wants. And then if you have some limits and must-haves, those you kind of, if you don't have them at all in your various alternatives, you can throw those away. But the alternatives that have the wants and actually work, you actually weigh those scores, and then you select the highest score, perform your risk analysis, and then select and prepare a trade study. And this kind of shows you basically what I was trying to show you there before. I'll let you read that separately. But this is one example of what you can use using this KT decision analysis. And this is where you would actually look at things that are go, must go, and you get rid of certain alternatives, but you use the others by looking at the raw score and multiplying them by the weight. Now, I actually, years ago, 15 years ago, I actually had to do a trade study for COTS, Enterprise Content Management System. It was commercial off the shelf. What can I do in order to actually make this work? And so what I did was I actually had to describe what an enterprise content management system was. Did somebody want to say? Okay. So you're basically looking at collaboration, people, processes, and automation. There's actually a way you can look at the architecture. And with that, I'm actually able to come up with various aspects of an enterprise contact system. So basically what I do is I have all these alternatives, but I'm looking at this over here is my product matrix. I look at the management platform. I actually have it on the next one. I look at the architecture, the features, the security, the vendor strength, support, and cost. Notice these add up to 100, and these down below each add up to 100. As you can see here, this equals to 100, but it's only 40% of level 3. But level 3 has several other things that make up the 25%. Now, the other thing that you have to look at, let me go back, that you have to look at is how do you explain your scale? If it says 1 to 2, what is your scale explanation? And that's where you actually say 1 means it's totally good, love it. If it's a 0.25, I barely make it. If it's a 0, it's unsatisfactory, and everything in between. So with this trade study, you can actually see I went through the spreadsheet and actually figured out the weightings of each of these aspects of the tools I was looking at. And it actually gave me, as I multiplied these together, an actual weighting for each of these products. And as you can see, document them one. And there are certain ones I couldn't figure out what the support or cost was. I erred on the fact maybe it's 100%. But even at that, it couldn't meet the criteria. Now, that had to be confusing, was it? Go ahead and unmute yourself if you have a question about trade studies. Because we're going to do an example, an exercise. All right, what I want you to do, is download this spreadsheet. I'm gonna, I've got a spreadsheet here. I think it's down below on the below, right? That's your project plan. Oh man, I forgot to give you guys the spreadsheets on the general channel, I believe. Let me see if it's there. If it's not, I'm gonna have to move it up there. Okay, give me a few seconds. Oh, you know what? Do me a favor. Go to your what is this, Blackboard. Go to class folders, which were there. Go to 5. You'll see lecture notes. Read it, lecture notes. Go there, and go down below. You'll actually see here. Let me turn that off here. Oh, you actually had some. Oh, I wonder why they thought they didn't. Right here, you'll see the trade study Excel spreadsheet. So go ahead and download that into your computer. And then one of you go ahead and open it up within your team. So go ahead and go into your team. When you start a new conversation through Meet, go ahead and have one of you open it up. And one of you should be able to fill it out. Okay, so let me go ahead and open that up so you can see what it looks like. All right, exercises, working files. Oh, nope, that's not it. Give me a second here to find it. See, I kept it down there. Exercise PowerPoints. Where are you? Okay, I must have. It's the same one I use for all these things, so that's probably why they're not there. Okay. Oh, there it is. Oh, that's team 2. That's not what I wanted. All right. Still, it'll give you an example to look at. You see if this will come up. There we go. Wrong one. All right. So basically what you're trying to do is fill out this spreadsheet. So go ahead, and one of you should be able to open it up, and you should be able to work together on just doing 1 through 9 is basically what you're doing. So fill out your problem. Do you guys remember where you put your problem statement? You put it in your files, and I believe it's exercise 1 was your problem statement right here. So you just copy that and put it in there. You have your problem statement. Then start discussing among yourselves, what do you want from a weighting for comfort, safety, fuel efficiency, reliability, muscle, transition, and cost. Once you do that, you figure out your weighting for each one. So if your comfort's at 20%, you're good there. But how do you split up between your rear seat room and the number of back seats? So this kind of gives you even a better fidelity on what you're looking at. Then once you do that, you actually go in and start looking at the specs that are here. And you say, well, looking at the fact that this has 86 inches, I should, through the weights, 86, it should be a half, right? So that, and remember, you can actually change this as you go along. So notice this is 0.25, that's a 1. It doesn't have a backseat, 0. So you're actually giving you your score. This score is calculated based on the lower level. And you do that for each car as you go in. Now, the reason I'm going to give you time to do this, now notice step 8, you finish that one, right? And then the results, you have step 9. In other words, once you're finished and you have a list over here, look at the highest one. You hear number 1 is Batten. Look at it and say, hey, does that make sense? Now, you'll be looking at these aspects of the car, right? So if you say liege, and depending on what you are, does this make sense to, for your what you've been assigned, right? Let me go back to here. All right, right here you were assigned, I believe this is number 2. You're a midlife man at crisis. So you should be able to pick all those up as you're going forward. If you can't remember that, remember in your team channel, I explain what your stakeholder is for the car example. This is commuters. Number 2, they have, I believe, midlife man, and the stakeholder here for number 3 is a family, and I believe this is a student trying to get to class, right? College student. So remember, those are your main things. You already have your things. So what I'm trying to do is get you to go through the entire aspect of what it is to do a trade study. What's important about this is this will lead into you understanding the homework that I'm going to give you. So understanding this, do it as a team, but you're going to have to do it individually for your homeworks. All right, let me leave this open for questions. Any questions? Because I'm going to give you a good half hour. Get back here at 6:15, and we'll see where you're at. I am going to probably have you guys either go ahead and upload your finished spreadsheet in your file section, and I'll upload, you know, I'll open it and we'll look at it together. That way you can explain, you know, how you came up with your trade study. Nothing? Just unmute and say you're doing good. Doing good.
Yeah,
All good.
All right. Thank you. All right. So go ahead and get into your teams. Download. Go to your go to Blackboard. Download these things. I didn't know I have these lectures. I have to move. I have to turn them off as we're doing that. And go ahead and do your trade study. Okay. All right. We'll see you in about half an hour. I know this is going to take a while. So do the best you can. All right. All right. Now, I don't believe, let me check one more thing before you go. Let me just check here. I don't think exercise 2 did, okay. So you may want to open this up in order to figure out where you're going to go. But eventually you'll look at your results. But we'll look at the spreadsheet, okay? But this gives you an understanding of what you need to follow, okay? So 2 things, the spreadsheet and this PowerPoint. All right? All right, guys, you should have everything you need. Let me know if anything is amiss or you don't understand, okay? All right, guys, we'll see you in a half an hour.